This is Euclid Book 8, proposition number 12, and here's the diagram. All right, let's get started, shall we? Between two cube numbers, there are two mean proportional numbers, and the cube has to the cube the ratio triplicate of which the side has to the side. Okay. Now, what is a cube number? Well, 8 is a cube number. How do we know this? Because if you take 2 and you multiply it by 2, you get 4. If you take that 4, then you multiply it by 2, you get 8. So basically you're doing 2 times 2 times 2. That's where they come up with this. Okay. Let A and B be cube numbers. And let C be the side of A and D the B. Okay. So these are cube numbers. Alright? Now we could say, well, A is 8 hypothetically, and we could say that B would be 27 because 3 times 3 times 3 is 27. You don't believe me? Take 3 times 3 and you get 9. You take 9 times 3, you get 27. Okay? So we could say that. We're not going to, but we could. Those would be two cube numbers. Okay. And of course, C is the side of A and D of B. Okay? C is the side of A and D is the side of B. So far, so good. I say that between A and B, there are two mean proportional numbers, and A has to be the ratio triplicate of that which C has to D. For let C, by multiplying itself, make E. C times C makes E. And C multiplying D makes F. So, C times D makes F right over here. Okay. All right. And then we're going to say that D multiplying itself makes G. Here we go. D times D makes G right over here. Okay. And let the numbers C and D, by multiplying F, make H and K respectively. Okay. C times F makes H. D times F makes K. Okay? C times F makes H, and D times F makes K. That's how that one works. Okay. Now, since A is a cube and C its side, and C by multiplying itself has made E, therefore C by multiplying itself has made E, and by multiplying E has made A. Okay, so C times C times C makes E. Okay, that's where they got that from. And C times E has made A. Okay, so C times E makes A. C times E makes A. Okay. For the same reason also, D by multiplying itself has made G. D times D makes G over here. D times D makes G. Okay. So far, so good. And D, by multiplying G, has made B. So if we take D and you multiply it by G, you make B right over here. And since C, by multiplying the numbers C and D, has made E and F respectively, because C times C is E, we already established that, and C times D is F, we've already established that. Therefore, as C is to D, so is E to F. As C is to D, so is E is to F. One more time. As C is to D, so is E is to F. That's how we get that. Okay. This is by Euclid Book 7, proposition number 17. For the same reason also, as C is to D, so is F to G. As C is to D, so is F is to G. And this is by Euclid Book 7, proposition number 18. Here we go again. And again, since C, by multiplying the numbers E and F, have made A and H respectively, and you're sitting there going, what? Okay. C times E makes A. C times E makes A. Okay. And C times F makes H. C times F makes H. Got that so far? Hope so. Alright. Therefore, as E is to F, so is A, it's to H. As E is to F, so is A is to H. Okay. And that is by Euclid Book 7, proposition number 17. But as E is to F, so is C is to D. As E is to F, so is C is to D. Same ratio. Therefore, also as C is to D, so is A is to H. C is to D as A is to H. And we continue. Again, since the numbers C and D by multiplying F have made H and K respectively. Whoa. C times F makes H. C times F makes H. And D times F makes K. D times F makes K. That's how that one works. Okay. Therefore, as C is to D, so is H is to K. So you're probably sitting there going, what the heck is he talking about? As C is to D, so is H is to K. Same ratio. And that's by Euclid Book 7 by Euclid Book 7 proposition number 18 says it is. Again, since D by multiplying each of the numbers F and G have made K and B respectively, stop right there. D times F makes K. D times F makes K. D times G makes B. D times G makes B. Okay. Therefore also, as F is to G, so is K to B. As F is to G, so is K is to B. And that's by Euclid Book 7, proposition number 17. But as F is to G, so is C is to D, which we already established a little while back. Therefore, also as C is to D, so is A is to H, H to K, and K to B. Alright. As C is to D, so is A is to H. That's the first part of it. That's what they were saying. And of course, as A is to H, so is H to K. As A is to H, so is H is to K. And the last part is, as H is to K, so is K to B. As H is to K, so is K is to B. They're all the same ratio. Okay. Therefore, H and K are two mean proportionals between A and B. I say next that A also has to be the ratio triplicate of that which C has to D. For since A, H, K, and B are four numbers in proportion, therefore A has to be the ratio triplicate of that which A has to H. Okay? A has to be a ratio triplicate of that A is to H. That's what they're saying. And that's by Euclid Book 5, definition number 19. But as A is to H, so is C is to D. Therefore, A also has to be the ratio triplicate of that which C has to D. And that's the whole proof. Alright. I will tell you more in a future video. You stay tuned.